So let's take a look at this handle. I have removed the cable from it because I want to connect the button here and one more thing that I'm gonna show later. I have saved this outer layer of the cable that I hope I can reuse so it looks the same as before. I still don't know if I can use the speaker and microphone in this, especially not with new cables. But if I can't do that, then it's worth replacing them if I can have a button here instead. And the button I'm gonna put in there is this little micro switch that has 3 inputs. If I connect the first one and the middle one and then click it, then it's gonna close the circuit. So I'm gonna try to put this one directly inside here. It will add a bit of springiness, so it will keep this one up. And then it will register when I click. When I went through my stuff, I also found this little thing. If I keep it laying down like this, it gets 0 volt resistance. But if I turn it up like that, then there's no resistance at all. So if I connect 2 cables to each of these ends, then I can register if this handle is in stand position, right way up, or upside down. And when I just found this laying around in my box, I thought, why not just add that as well, just for fun. So I'm gonna add both of these 2 into the handle. The best, of course, would be if I could add them in here and then have some kind of socket that I can just connect a cable to, so I can remove the cable for debugging purpose and so on. But there's so little space, so I don't think I can do that. I kind of have to solder these just onto the cables that I have here that are slightly longer than this. So I'm going to have to solder this onto here, hot glue this in place, and then just drag this through this, and this will be permanently connected to the handpiece. But that's just how things will work. So let's find out if this all works. The red one is incoming 3.3 volts. And the other three ones are the outputs. So the green one is the button, and the other two shows the tilt. So what I'm gonna try to do is connect this to some LEDs to actually see that they output something. So the green one connected to the yellow one actually, because I only had two green and one yellow. And then the green ones will show the tilting. So they are receiving 3.3 volts when it's active, and then it's going out to ground through a resistor. Let's just hook up ground to one of those pins. They are all connected in that end. And then I'm just gonna connect this to this one, red to red. And now one of them lit up because it's apparently tilting. If I turn it like this, then one is lighting up. If I turn it over, another one is lighting up. So the flip occurs pretty much when it's level. So maybe it would be enough to just have one of them. But I guess this is more accurate. I don't really know what this is useful for anyways. Maybe something. Then we have this switch. So let's try to fit that into the handpiece and hopefully use it for something useful. So I ran out of battery on the camera when I was fixing this handpiece. So not all of it is saved. But I added the macro switch in here. And also the tilt sensor that knows which direction I'm holding this. And I also added this braided sock. That is the original part, so it looks like it did before. I think it goes really well, that green color and the brass or whatever metal that is, probably brass. So let's hook this up again. So now one of them is lighting up, and if I push the button, and the middle one is lighting up. And if I start to tilt it, then it switches. So I don't know the angle, if it's just a little bit tilted or all the way. I just know in which general direction it's tilting. But I still don't know what to use that information for anyways. So yeah, we'll see. Maybe I can do something fun with it. The last button to fix is this one. So this here is the button that gets pushed down onto all of this. And my plan is to actually replace this part with a more modern macro switch. Just because it takes less space and it is a bit more reliable, I imagine. I'm going to remove these solenoids and replace them as well at some point. Maybe I should do that at the same time. So first I have to solder on some cables to this macro switch. I want it to be off when it's open like this. No, actually I want it to be off when it's closed. So the exact opposite of what it is now. When it shows 0, then it's full flow of power. And when it's OL, then it's nothing. So if I change that one to here, then this is full power and that's nothing. So that's what I want. I want those two connected. So let's do that. This part is spring loaded. I can probably just put the solenoid under here and keep the rest as it is. And then I can, without the problem, also put this one here. Or maybe I actually should put it here now then. It's probably easier to just have it here. Or is it? If I remove this little part, because I don't really need that. And I put this one like that. And it's not going to take up as much space. Or maybe I can even put it like that. Yes, that sounds like a plan. So I'm just gonna hot glue this in place. Just add a lot of glue here. I should invest in a new glue gun because this is really... I'm pushing the limits of this one every time. Here we go. So now all the buttons should be fully operational. I put everything back together and there's only 2 leftover screws that I don't know where they're supposed to go. Hopefully I found that out in time. So let's try to use all of this together. Now I have these cables coming out from this button and from the dial. Of course, in the end it's gonna be the opposite, that it's this one going in. But for prototyping, it's good to keep things viable. So now it's time to hook this up to the Raspberry Pi. I'm not gonna use pins 2 and 3 like I did in the example, because they can also be used for other purposes, which means that when you start the Raspberry Pi, they might be set to output instead of input. And then I would need a few more resistors to avoid frying them if I'm really unlucky. When everything is set up connected later. When you test stuff out, it's not that much of a problem. So I'm just going to use those that are just for one purpose. General input-output, because they will be set to input by default and more safe to use in that sense. And I'm going to use the same colors all along, just because now it's so many of them, so it's gonna confuse me otherwise. So 3 volts from here into the board. And the way these boards work is that the edges here that says plus, minus, plus and minus, they are connecting all the row down. So when I put this 1 to 3 volts, then everything connected to this row can pick up the 3 volts. So it goes into the handpiece here, and it also goes into this one that connects to this one, and it also goes into through this green jumper cable, this red one, which goes to the dial. And then I connect my negative, the ground pin, from up here to minus, which means that it will connect to all of these resistors. So then I'm gonna connect the yellow one and gray one to the bottom ones like this. That's pin number 21 and 20. I'm gonna connect that one in between here, so it will either read 0 if this one is not active, then it gets the 0 from here, or if it's active, it gets the active number. And then the rest of them, the last pin here is ground pin again, so I'm not gonna use that for this, of course, because it's not a GPIO, it's not a general purpose pin. I'm gonna put in the second next one, which is pin 26. like that. Then we have the green one, pin 19. The ordering of the pins are quite strange. And then we have pin 13. And of course number 6. So now everything should be set up properly to use this in a Python script. I did some changes to this circuit. It's not only recommended that you connect the button to ground when it's not activated through a resistor, but also that you connect a resistor to the pin itself. So now I'm setting a 10 kilo ohm resistor from the button output to the ground, and then between the button output to the pin I'm setting a 1 kilo ohm resistor. But now all the buttons should be set up properly. There are 6 of them, 2 in the dial, 1 here in this one, 2 that controls the tilt, and 1 for this here. So let's test that everything still works. Import GPIO and import time, just like before. And then we need the pin numbers. So there's yellow, 21. Then let's just loop that. So then I can, for pin in pins, I'm just going to loop through all of them and set up pin. So now this pin variable will be represented by each item in this list. So it's going to set up the pin to be input. Then let's make another try except, just so I can clean up the pins in the end. While true, sleep 0.01, time.sleep, of course. And then for pin in pins, let's look through them again. GPIO dot pin. And I want to print that, of course. Usually when you print something, then it's gonna jump to a new row directly after. But if you don't want that, then you can add your own ending. So in this case, it's just gonna add a space instead of jumping to a new row. So they all will be on the same row, basically. So after that loop, I want to add empty print, so it jumps to a new row after all of them has gone through. This should just print out all of them. No. Oh yeah, of course. Of course you have to add the exception as well. Keyboard interrupt. There shouldn't be a colon there. GPIO dot clean up, like so. So now all of them are off except one, and that is hopefully the one that shows that the tilt, that the handle is on in the right direction. So if I lift this one up, then another one gets activated too. If I turn this upside down, then it switches which one gets activated of those two. If I click this button here now, then that one also gets activated. So those 4 all works. If I dial a number here, then the first 2 gets activated. I can see a little bit of flickering, which is bad. But if I let go of it, then it looks correct. I can also notice that this handle is so level, so the smallest motion disables it. I think what I'm gonna do for the logic of that tilt function is that if it is in this position, then it checks the other channel. If that gets active, then it switches to that position. And if it's in this position, then it checks the first channel. If that's active, it switches back. So if it's in this state and it gets a 0, then it won't consider that a flip.